The next conic section that we're going to look at are ellipses. An ellipse is basically an oval, but there's maybe some more mathematical restrictions for what would be an ellipse. An oval is probably a little bit more general, but anyway, an ellipse looks like an oval, or it's a circle where I like to think of it as just one of the radiuses is stretched, either to the side or up. One of those is stretched more than the other. These are pretty simple to graph, but let's look at some of the parts of an ellipse first, because an ellipse is going to have more pieces and terms than circles or parabolas have had. So here's an ellipse. I did not draw that freehand. The iPad helped me do it. That's why it looks so nice. But here's an ellipse. And the way that we make an ellipse, instead of choosing just one center like we do for a circle, we kind of choose two centers. So I don't know exactly where they would be for this one, but we would have two centers, and each of these is called a focus. So plural, these are called foci. There's two focuses. The plural for that is foci. So each of those is a focus. And the way that we generate the ellipse is it's all of the points so that the sum of distances to each of the two foci is constant. So let's say that this is distance 1 and this is distance 2. If we add those together, we get the same thing as if we added distance 3 here and distance 4. So it's kind of like we have one radius coming from two different points, but that's how we generate the shape of an ellipse. In class, ask me to show you on the board how we can, or what little tool that we can use to draw an ellipse. Okay? But foci are the 2 points in the middle that kind of determine the rest of the ellipse. Okay? So we have two foci. The line that goes through those from endpoint to endpoint is called the major axis. And the points on the ellipse that the major axis hits, those are the vertices. So each of those is a vertex, the furthest out points. Okay? Perpendicular to that, through the center of our ellipse, so obviously right here, this would be the center, that point in the very middle. Through the center, perpendicular to the major axis, is the minor axis. And the points that those hit, that are closest to the middle, those are called the co-vertices. Okay? So the vertices are just going to be the points that are furthest apart. Co-vertices are closer. So even if we have an ellipse that opens up and down, your vertices are going to be vertical to one another on this one. So vertices would be the top and bottom there, and the co-vertices would be the ones on the sides. Major axis is always the longest distance across. The minor axis is the shortest distance across. I think that sums it up for all of the important parts of an ellipse. Up next, I have you using Desmos again, so plugging in a couple equations, moving things around. I think the easiest way to think of an ellipse is it's a circle, but we are changing the radius for x, or we're changing the radius for y. So try to think of it that way as you play around with the different values on Desmos.